Hey Shustik, come to my house. Let's solve our homework together. Okay, done. Let's go. Would you like to change? No, Vidu. Thanks. Let's move on the assignment. I have to return home. Sure. Let's start with fluid pressure. Does fluid exert pressure in all possible directions? Yes, it does. The molecules in fluid can move up, down, and sideways, that is laterally. They continuously collide with each other and with the sides of the container. While doing so, they exert thrust on the wall of the container or any object in the fluid from all directions. This gives rise to fluid pressure in all directions. I think I can solve. But before that, we need the expression of pressure at a point inside a liquid. Now think of an example. When a man swims under water, he feels pressure upon his eardrums. The deeper he goes, the higher the pressure he feels. Can you tell me why does this happen? Here you can see a static liquid column of height h. Now the volume of this liquid column would be V equals to height into cross-sectional area. Now see, the cross-sectional area is given here, that is capital A. So volume would be height, that is h, into cross-sectional area, that is A. Now we know the pressure is thrust by area. So what is thrust? Thrust is the weight of the liquid column of height h. Now here in this case we are calculating pressure at the bottom of the liquid column and the height of the liquid column, that is h. Now thrust is weight, weight is equals to mass into gravitational acceleration. So it is written here m into g. M is the mass of the liquid column and pressure is weight over area, so mg by A. Now we know that mass is equals to volume into density. So we have calculated volume, that is h into A, and suppose the density is rho. So it will be rho into A into h, and here is g also. So we have rho into A into h into g and divided by A. Now A cancels. Now we have rho g h. Now as the person goes deeper, the depth from the water surface increases. Therefore, he feels more and more pressure. You explained wonderfully. Thanks. But I couldn't understand one thing. What is it? If we take a tub and a bucket, both are of same height, and we fill those with water, then what will be the pressure at the bottom of both the containers? I mean, will it be same for both cases? Of course, it is same for both the cases. You explained how to measure pressure at a point inside a liquid. Now see the expression for pressure. Is there any area present in that expression? No. Then fluid pressure doesn't depend upon area. So for both the containers, pressure is same at the bottom. You explained superb. So if a man swims at 10-meter depth in a pond and he also does the same at the same depth in a sea, he would feel same pressure. Your assumption would be correct if both pond water and sea water have same density. As density of the liquid increases, then pressure exerted by the liquid also increases. We should remind this. Okay, do you know Stevens' law's application? Oh yes, according to the law, a liquid seeks its own level. You take tubes of various shapes connected to each other by a horizontal pipe at the bottom, and you pour any liquid through any one of the vertical tubes. You will find that the level of liquid is same in all tubes. Can you tell me what should be the upper surface of a stationary liquid? I mean, is it horizontal? Of course, a liquid is at rest, that means it is in equilibrium. Now, in equilibrium state, the upper surface of liquid is always horizontal. Oh, it's late. Please have some snacks or something. Absolutely fine. Let's have a discussion on atmospheric pressure. Can you define atmospheric pressure? It's simple. The Earth is surrounded by an envelope of air called atmosphere. This atmosphere extends up to a height of about 500 km and is composed of a mixture of gases. The pressure exerted by these atmospheric gases on the surroundings and on the surface of the Earth is known as the atmospheric pressure. Yes, experimentally it has been observed that at sea level approximately 76 cm of mercury column exerts the same pressure as the atmospheric pressure. Again, the atmospheric pressure at sea level is 1 atmosphere, but it decreases as we go up from the sea level due to a decrease in the density of air, as well as the decrease in the height of the air column. The atmospheric pressure increases as we go below the sea level, for example, deep inside a mine. Do you know about weather forecast? Not much that, Shostik. Let me call my father. He can explain well. Okay. Father is coming.
Shostik, how are you, son?
I'm fine, uncle.
Okay. What are both of you up to?
Shostik was asking about weather forecast. Yes, uncle. I have a question.
Okay, what is it?
Uncle, does atmospheric pressure at a given place depend on the weather condition such as temperature, moisture?
Yes, Shostik. Temperature affects the density of air. If temperature increases, density of air decreases. Now, less dense air exerts less atmospheric pressure. A fall in pressure due to rise in temperature portends a dust storm. Again, humid or moist air is lighter than dry air. Therefore, a rise in humidity results a fall in pressure, that is depression. This condition indicates rainfall. If the fall in atmospheric pressure is sudden, it is forecasted for a storm or a cyclone. Did you hear about Fortin's barometer?
We don't know so much about it. Father, please tell us about Fortin's barometer.
Sure, son. Fortin's barometer is an improved form of mercury barometer, which is used for the accurate measurement of atmospheric pressure. You know that for a given liquid at a given place, the pressure at a point inside a liquid is directly proportional to the height of the liquid column. So, if a height of liquid column decreases, it indicates that there is a fall of atmospheric pressure. And if the height increases, therefore there is a rise of atmospheric pressure.
Father, why did you mention for a given liquid at a given place?
Oh, yes. For a given liquid indicates that density of the liquid must be constant. At a given place indicates that gravitational acceleration, that is, g, must be constant.
But uncle, we read that gravitational acceleration, that is small g, is a constant quantity on the Earth's surface.
No, son. It's not a constant quantity. G varies from place to place on the Earth's surface. It is maximum at the pole but minimum at equator.
Father, what were you telling about Fortin's barometer?
Fortin's barometer consists of a thick-walled glass tube of 1 meter length. The glass tube contains a cistern of mercury. The bottom of the vessel is made of leather, which can be raised or lowered by means of a screw provided below. The whole barometer is enclosed in a brass tube and glass windows, which are provided to take readings. A brass or ivory index is fixed vertically to the lid of the vessel containing mercury. The tip of this index coincides with the zero of the vertical scale on the glass tube. Now, from such arrangement, you can note the length of fall or that of rise of mercury column in the barometer. Then you can forecast on weather.
Thank you, uncle. I understood very easily. Yes, father. I also understood.
Okay, then you carry on your discussion. I have to go now.
Oh, Vidu, I also have to go. Okay. Bye, Shostik.